Okay, so now we're going to do some examples. So I'm going to work some examples with you and show you how you go about proving some of these trig identities. So as I said, we'll start with something with easy examples and then we will move our way up. Okay, so for a first example, we'll take sine x over tan x, and that's supposed to equal cos x. All right, so the first thing that I told you that you needed to do in the list of little rules or steps to follow is to determine which side you want to work with. And you go with the messy side. Well, there's two trig functions over here, only one on that side. So we're going to start with the left side. So the way you do a proof is you determine which side you're working with, the left side or the right side. So if it's the left side equals. If it was the right side, but right side equals. Write down exactly what's there. Do not make any changes to it. Put down what was written in the question. So it's sine x over tan x. Then at this point, one of the next things that I told you is anything that's not written in terms of sine and cos, you want to change that. So this is a tan x. We want to get rid of that. Well, tan is equivalent to sine over cos. So we make that little switch. This is something being divided by a fraction. You learned in elementary school that when you divide by a fraction, you flip it over and multiply. Or in correct terms, you multiply by its reciprocal. So what that means is leave the sine x that's on top. To that, you're going to multiply by this guy flipped over. It becomes cos x over sine x. Now, this is all a multiplying and division question. Anytime you see something in the numerator position and it's exactly the same in the denominator position, they wipe each other out. Well, if we take those out, all that's left is cos x. And if we look over onto the right side of our equation, that's exactly what's there. So we finish this off by saying it's equal to the right side. I started with the left side and I turned it into the right side. 99% of your proofs are going to work like that. Okay, you're going to start with one side, you're going to turn it into the other. This is what a trig identity proof looks like. You determine which side you're going to work with, you write it down, and then you make some changes to it until you eventually get what you want on the other side. Notice the equal signs run down the left-hand column. I'm not going equals and then equals and carrying on till the page runs out. You go straight down. Okay? Start with one side, end with another. Okay, there's a first example. All right, let's try another. Okay, in this next example, so example number 2, not much more difficult than the previous example. We will take tan x over cos x equals sine x over 1 minus sine squared of x. So we have this. All right. At this point, they're both sort of equally messy, so it doesn't really matter which side you work with. I'm going to choose to work with the far side, the right side. And I'm going to try to turn it into this. All right, so again, once you determine what side you're working with, write down exactly what's there. All right, let's focus on what's sitting in the denominator. There's absolutely nothing we can do with this. When you have sine x or cos x, there's nothing you can do with it. But this one is 1 minus sine squared x. And in the Pythagorean identity that I gave you, we did a rearrangement where we isolated cos squared x by itself, and it was equal to this amount. So we are going to replace 1 minus sine squared x with what it's equivalent to, which is cos squared x. Now, don't totally ignore the other side, which I mean don't ignore the left side. This is what I want to eventually get to. All right, what I'm going to do with this denominator is I'm going to break it up a little bit. This is the same thing as saying sine x over cos x times 1 over cos x. Okay, if we put this back together, sine times 1 is sine x, cos times cos is cos squared x. But now, in doing this, I can give this another name. Sine x over cos x is referred to as tan x. And if we want, for one step, we can just write this down the way it was. Now let's put them back together, one on top of the other. So in doing that, just simply multiply the tan x by the 1, which gives us tan x. And the cos x just remains on the bottom. And if we look over on the left-hand side, that's what's sitting there. So again, we started with the right this time, and we turned it into the left. Okay, and in the same way, I could have easily worked with the left side and turned it into the right. So it's your choice. In this one, there really was no big difference on which side was messier than the other. All right, let's try one last example. Okay, in this last one, we will try to prove that sine squared x plus 2 cos squared x minus 1 is equal to cos squared x. All right, definitely in this example, we can see that the left side is much messier than the right side. It has 3 terms, and over on the right side there's only 1. So I'm going to start with the left side. And again, as I said, write down exactly what's there. I also said don't ignore what's on the left side, because that's what we want to get to. So notice what's over here. Simply a cos squared x. So what that tells me, because I just have a cos squared x, I need to get rid of this, for sure. It needs to go. So again, if you go back to the Pythagorean identity, we saw that there's another name for sine squared x, and it's 1 minus cos squared x. Then write this down, what's left, the plus 2 cos squared x, and the minus 1. All right, now notice on the two ends, I have a positive 1, and I have a negative 1. They wipe each other out. Then these guys are like terms. Okay, when you were learning algebra, you can only add together terms that are like. Same thing with these trig functions. You can only add like trig functions. I have 2 cos squared x's here. I'm taking 1 away. That leaves me with one of them. And if I look over on the right side, we see that that's what's sitting there. Again, started with the left side, we turned it into the right side. Okay, so that ends this little segment. I'm going to come back in a little bit, and I'm going to put up a part 3, a little bit more difficult trig identities to prove. So I'm going to do 2 more parts, and they will increase in intensity as far as how hard they are compared to the last ones that we have done. But again, using the little tools that I gave you, should be no problem for you to prove these.